Hi, welcome back to my channel. This is Harshita from Sri Venkateshwara College of Engineering from ISC Department 3rd Sem. Today we are going to discuss about OS, which is about page faulting. If page is needed that was not originally loaded up, then the page fault trap is generated. Step in handling a page fault. First, the memory address requested to first check to make sure it was valid memory request. Second, if the reference is to an valid page, the process is terminated. Otherwise, if the page is not present in the memory, it must be paged in. Third, a free frame is located possibly from a free frame list. A disk operation is scheduled to bring a necessary page from a disk. After the page is loaded to the memory, the process page table is updated with a new frame number and the valid bit is changed to indicate that this is now a valid page reference. The instruction that caused the page fault must be now restarted from the beginning. Pure demand paging never brings a page into the main memory until it requires. We can start executing the process without loading any of its page into the main memory. Page fault occurs for the non-memory resident page. After the page is brought into the memory, the process continues to execute. Again, page fault occurs for the next page. Hardware support. For the demand, paging is the same hardware is required as the paging and swapping. Paging table has the ability to mark an entry valid through the valid bit. Secondary memory. This holds the page that are present in the main memory. Performance of the demand paging has a significant effort on the performance of the computer system. Let the P be probably the page fault. Effective access time, which is 1 minus p into me plus p into page fault, where the p is equals to page fault and ma is equals to memory access time. Effective access time is directly proportional to the page fault rate. It is the important to keep the page fault rate low in the demand paging. Considering the paging system with the page table stored in the memory, if a memory reference takes 200 non-seconds, how long does the page memory reference takes? If we add the associate register and the 75% of the page table reference are found and associated register that are the effective memory reliance time. Assume that the finding page table entry in the associative register takes 0 time if the entry is free. 400 nanosecond, 200 nanosecond to access the page table and the 200 nanoseconds to access the word in the memory. Effective access time is equals to 0.75 into 200 nanoseconds plus 0.25 into 400 nanoseconds is equals to 250 nanoseconds. Demand paging example. Memory access time is equals to 200 nanoseconds. Average page faults serve time is equals to 8 millisecond. Eat 1 minus p into 200 plus 2 8 milliseconds. 1 minus p into 200 plus p into 8 lakhs is equals to 200 plus p into 7 lakh 99,800. If the one axis out of 1000 keys of page fault, I then I8 is equals to 8.5 microseconds. This is the slowdown by a factor of 40. Copy and write. Technically, technique to initial allow the parent and the child to share the same page. This page is marked as a copy on write page if either process writes a shared page. A copy of shared page is created. Example, if the child process tried to modify the page containing position of the stack, the OS recognition then is an copyright web page and creates a page of this page. and the maps it on the address space of the child process. So the child process will modify its copy page and not page belongs to parent. The new page are obtained from the pool of the free pages and the free previous contents of the page are realized before getting them into the main memory. This is called zero on fill demand. Page replacement. Page replacement policy deals with an solution of the page in the memory to be replaced by a new page that must be bought in. When a user process is executed, a page fault occurs. The hardware trap out to the operating system, which checks the initial table to see that this is the page fault and not a legal memory access. The operating system determines where the derived page is residing on the disk, and this finds that there are no free frames and the least free frames. When all the frames are in the main memory, it is necessary to bring a new page to satisfy the page fault. Replacement policy is concurred with the selecting a page currently in the memory to be replaced. The page it is to be removed should be the page that is lost in the page referenced in the future. Working of the page replacement algorithm. Find the location of the derived page on the disk. Find the free frame into if there is a free frame use into the otherwise use a replacement algorithm to select a victim. Write a victim page to the desk. Change the page and the frame tables accordingly. Next, read the derived page into the free frame. Change the page from the frame table. Restart and the user process. Thank you.